So I'll just repeat the title again: From Instruments to Intelligence, Scaling ASM Across the Lab Enterprise. We've got 3 speakers for this talk. The first is Wolfgang from ZONTAL, and the next 2 are Chris and Vinny, both from MSD, and I will pass it off to them.
All right, great. Yeah, so I promise you I am not giving a presentation. I'm just going to introduce the team's effort here, and then I will turn it over to Chris and Wolfgang. Okay, so a couple of things that we wanted to accomplish in this session. So you might have noticed we scheduled an hour. It's a long presentation because we're not going to talk for an hour. What we actually have in here is probably 3 talks combined in 1 or 3 segments, and we'll take pauses in between it. And so what we really want to do, and definitely for folks online, I'll monitor the chat. Please put questions in the chat. We're going to have breaks at regular intervals. For folks in the room, you know, we'll go a few minutes and then we'll break and pause. But we want to have this be an interactive conversation. The first portion that you're going to see is what Merck, you know, we've been journaling for you live, what we've been doing the last few years with adopting ASMs at Merck. And so this is the latest installation. So Chris will take you, Siegler, my colleague at MSD, will take you through the first section. And we'll tell you the latest, you know, for those who've been anxiously waiting for the next installment. We'll let you know how it's going at scale. Then for the techniques that we've been working on, and then we'll transition into some additional ASM instrument classes that we've been putting, and share with you all the learnings, and let's have a dialogue about it. And we want to share, you know, we want you to benefit from our learnings, give us some additional ideas. Then we're going to pivot, and Wolfgang Colsman from ZONTAL will take over, and we'll start talking about what we're starting to do now and what we'll be doing in the future, AI enabled. And then we'll tie it all together of what's possible. So with that as the background, again, you know, please you're not interrupting, inject yourself in the conversation. You want it to be a conversation. So maybe just 1 or 2 slides to sort of set the stage. So you know, I kind of alluded to this during our keynote speech presentation. We all like to say we have fair data, right? It sounds so good, right? It's fair. My data is fair. Your data is fair. But when we actually look at it, we can't answer questions about a portfolio, or we talked about it in some of the earlier presentations. What's happening in this project? How do I connect clinical data to development data, historical data? How do I compare across sites? One of certainly the use cases that we talk about internally at MSD all the time: investigations, root cause analyses. Things that you try to figure out during development, what, you know, at a multi-parameter interaction level, can't do any of these things. So, you know, the question first for me is, do we really have fair data? I think during these conversations, maybe yes, maybe no. Sometimes we're being a little liberal with the definition of fair data. Fair enough data is probably a better way to look at it. But I think the other important concept that we'll introduce here, and we'll just touch on in the next slide, but then Wolfgang will go into that in more detail in the presentation a little bit later on in the afternoon, is fair as an idea. You know, one of the most cited research publications about data, really the most cited of all time. It's important, but it's still a description of a quality. It's a target. It doesn't actually tell you how to get there, and it doesn't actually tell you how you make decisions. So I'm just going to present this very quickly to you now. Again, it's something from the citation for the presentation later is up there. And this is something that ZONTAL has recently published. I think it's really useful maybe to frame this conversation. These are principles. Think of it as, how do you operationalize fair data? And I'll just leave it up here for a moment so you can kind of look at the principles. But what we'll mostly be talking about, I think, hopefully, and starting to share examples through this workshop, but even through this Merck MSD presentation here, I have to keep correcting myself. MSD presentation here is really the first 2 letters: integrating your data, capturing the standardized format, at the source, so born fair, via governed pipelines, and then properly contextualizing it so that you can draw inferences between those durable relationships between your entities that are really going to help you get to the left-hand side, which is where I think all of us want to be as soon as possible. If you've got that good quality data automated, then how do you actually look at data across, so analyze the data across your ecosystem, and then ultimately, hopefully with leveraging the power of AI, how do you actually make better decisions? Basically, so that's what this is all about. This is all means to get to that end. So keep this in mind, and let's come back to these principles, and Wolfgang will take us through this in a lot more detail later on this afternoon. So with no further ado, I am going to step aside and introduce my colleague Chris Siegler, who will take you through our journey, and hopefully we'll be able to demonstrate, just take this here, that we're starting to use these principles.
Thank you, Vinny. All right, so for those in the room, this is an eye chart. Please, someone, can you tell me what symbol this is? What character is this? Anyone, raise your hand. Someone. Yes. Micro symbol. Okay, you're right. That's a micro symbol. What about that? I know it's blue, but what character is that? Somebody else. Is that a micro symbol? Yes? No? Well, everyone that said micro, you were wrong. Right? So on the left-hand side, the black one is a micro unit, Unicode B00B5. On the right-hand side, you have mu, right? Which is Unicode 03BC, right? You might think that I'm crazy, but these really are two different characters. To us, adding this contextualization is really easy. We can realize, oh, that's microliters. That's not U-liters, it's microliters, right? Computer systems, AI, can't tell the difference. It actually sees them as two very different characters, which becomes a problem. Something so simple that a human can do becomes incredibly difficult and complex for AI, right? So why does this matter? Well, congratulations. I just talked about contextualization and why it matters, right? And that semantics is a real important thing, right? Yes, I know I was being pedantic, but, and for those of you in the US that back in the 90s, growing up with cartoons in the morning, it was a very popular thing. I think NBC did this or whatever. The more you know, right? But the problem here is, and what I'm trying to get across, is things that people think are so simple to do. When we actually start getting into standardization and harmonizing, it becomes very difficult when we start digging into the details, right? Because you're right, micro versus mu, who would have thought, right? All right, so, and this is a prime example on, especially in today's day and age. Yeah, this carpet is bad, but
I'm gonna make a decision.
you don't want me to fall and then have a huge issue, right? Anyway, so it's really important, right? We spend all this time with Allotrope. They've invested a lot into doing the standardization and harmonization, contextualization, right? So that we can end up creating vast data lakes, right? That is more structured and easier to be used for insight generation, right? Especially in today's day and age, right? Now with AI, we want this to be AI-ready data, right? And so I think more than anything, Allotrope and what its vision is going to be more and more important as we move forward. So as many of you, for some of you that might have been there or online when I talked back in fall, whatever we were in Boston, you've seen this slide. I've talked about it, right? As Vinny said it, MSD has been constantly kind of live journaling. It's been maybe on a quarter or biannual basis at all these Connect meetings, but we've talked about this, right? So as a user in the lab, as a user scientist in the lab, we oftentimes start on the left-hand side with our electronic notebooks or our LIMS systems, right? That then push data, sample information, create sample sets for doing injections in our softwares, right? Then we create data, hopefully, and I'm sure there's going to be some talks or some free talk later or discussions later. But we'd really like to have that, right? From our perspective, vendor native ASM generation would be very key and very valuable, right? There are things that the vendors know much more about their own software and their own instrument than others, right? We're also in this, as you'll see as we move across, right? If not, though, we have to have some other system do a transformation for us, right? So that we can get our data and get our ASMs, put them into the cloud, right? Oftentimes we're doing everything, especially when it's AI related, it's got to be in the cloud, right? So we create our data product, our ASM data product, and then that, along with, say, the experimental information for what experiment was run, that's another data domain, right? Add in sample metadata, that's another data domain. Add in process data, now that's a different data domain with its own data product. We can combine them all together into our data lake so that end users, such as research scientists, data scientists, I guess I should add an additional one, leadership or root cause investigations, right? To be able to interface with our data and take advantage of AI to help them glean information or gain an understanding of what's happening in their process or their labs. So as we've moved on, right, so our first one we showed back in Boston was we were working on Empower data, right? It's one of the biggest used applications at MSD. Q1 this year, we're just finishing up, so maybe it didn't quite hit Q1. We are finishing up our NovaFlex 2, so we're talking about a solution analyzer, and we're getting ready in kind of overlapping, ready to start releasing CDEX after we're done with Flex 2. But then we have a number of different instruments and instrument softwares that we're going to need to enable throughout the rest of this year so that we can focus on a package released for some of our actual pipelines so that we can show to our leadership the value of this, right? Because I think Dr. Lopez talked about it earlier today. She talked about ROI, right? Return on investment. We spend all this time to do all of this. What are we getting out of it, right? So we need to be able to show to our leadership that it's actually value added. Obviously, while we started with Empower, right? Now that we bring in Flex 2 data, we need to make sure that the things that are interoperable across those two different, right? So like sample identifier, we need to make sure they map correctly. Device type, right? There'll be different device types, but we want to make sure that that same information gets captured within the same ASM field. So it becomes very important to harmonize both within a sample class, so going from like OpenLab CDS to Empower for chromatography, or going to other outside instrument families. Now, I guess I kind of talked about that while we were going on, but one thing about solution analyzers, you'd think it's one instrument. It's pretty simple, right? It's not Empower, it's not chromatography where we've got 5, 6, 7, 10 different instruments and instrument types, maybe hundreds once you start combining all of your different detectors. Solution analyzers, while simple, they create one CSV, one row in a CSV for all of your one sample. It's not. It's actually a blood gas analyzer. It's a pH meter. It's an osmometer. It's a cell counter, and a metabolite analyzer, right? So 5 different instruments all combined within solution analyzer. So one thing we've done along our journey is to try to explain to folks how difficult this is, right? So from the beginning, when we say that we want to have an ASM, and we end up going through the entire path to end up getting to an ASM, It taught, and again, going back to Dr. Lopez, right? She said this morning, it takes a village to do all of this, right? It's not just IT. It's just not an allotrope SME. You need instrument SMEs. They got people that are using the instruments in the lab because you have to understand the lab workflow process, right? You also need the automation SMEs. At MSD, we call them automation SMEs, but these are the folks that have taken it up. They might know some coding ability themselves, so they create a bunch of small little things that get deployed to try to automate things out into the labs, but it's not scalable, right? So we have to combine all of them throughout this entire process to end up actually releasing, which is right here, phase 3, right? We release those ASMs percolate into our data lake, but we're not done there. We've created an ASM, it's gone a long way, but I think Vinny talked about it. We have to do phase 4. That's where we get our business value. That's where we actually start to get that ROI. So throughout our journey, I think I probably talked about this a little bit as I've gone on. Well, one instrument is not just as simple as one format, right? We have complexity across all of our different instruments. Some create lots of columns, lots of rows. Some are simple, but still are complex, right? And you have to factor in all of those different structural differences when creating a converter. And scaling is not linear, right? Because of all of those mappings, all of those different customizations, right? You end up requiring a lot of the SME dependence, which burdens them over their job, right? They're lab scientists. What's their job? To do the science, right? So we have to be able to set aside time for them to do this to save them time on the back end. And then obviously, as we move forward in for our regulatory space, right? We not only have to be able to show that we can do this once, but with all of the various, right? Sometimes you only use the blood gas analyzer as a solution in the solution analyzer, right? Sometimes you use 3, sometimes you use all of them. We have to validate it to make sure that the ASM matches what we originally found in our source. So what does this all lead to? Testing, right? We'll see converter development takes a lot of time. We'll see from some talks and some work that we've done with ZONTAL, Wolfgang will talk about this. We can speed that up. So now what becomes the next bottleneck? It's the testing. It's the validation that we end up having to do. So what'll really help is if we can have converters be reusable, right? Have their coverage. We also need to try to cover and map as many of the different parameters as we need possible, because while your end user in the lab might only care about result X, Y, and Z, your data scientists, they actually don't care about X, Y, and Z. They care about your raw data or combining certain data to do statistical modeling, which requires a much larger and broader data set. And so some things that we've done, we found for consistency, right? We've designed ways to be able to have a base mapping document for some key parameters to make sure that, like, when we have a TCAN Magellan or a Roush CDEX, Roush is always, right? You could call it multiple different things. It's either the brand name or it's the manufacturer or it's something else, right? So we make sure that we always map that to the same thing across all of our instrument families. The same thing with Magellan. Magellan's actually the software embedded in the instrument. The model is a Spark or an Infinite, right? So making sure that you actually correctly call things so that when I do an AI chatbot in the future and I go, show me all of the Roush CDEX, right? It'll actually find things correctly. And then again, treating converters, right? A converter that ZONTAL develops for J&J, it really shouldn't look any different. Maybe Maybe it maps some different custom fields into a custom field document for J&J, but our MSD CDEX ASM should look the same as J&J's, right? And so that'll also help us speed up from a vendor perspective of having converters that are reusable and interoperable. Because what happens if tomorrow J&J and MSD decide to collaborate on a project? We want to be able to share our ASMs, right? And be able to look at data across the two different companies. Right, okay, so I kind of beat myself to the punch on that one. I apologize on that one, but again, right, so as I said, and as I think others have said, it does take a village, right? So just to be able to do the Empower and the Flex 2 that we've already been working on, right, it's taken all of these people. So problem is, this is unsustainable, right? If we only produce a new ASM converter for every, say, quarter or every 4 months, by the time we get through, we'll say 50, just to make it a rough number, of the number of different instruments that might be used across MSD, right? You're talking forever. We don't have that time anymore, right? We don't have that luxury to wait. So we have to figure out a way to do this at scale. So Wolfgang?
Maybe actually before you.
That's right.
Yeah, let's just see, just because there's going to be, yeah, let's just see if there's some questions. You can answer it, yeah. But just for either in the room or online, if there are questions online, just raise your hand or put them in the chat. Let's cover the first block, just so you don't have to remember your question.
You talk about this mapping file to build all this connection, all this contextualization. So I guess that building is one thing, but then maintaining them is other. How do you tackle that? Because fields can change, new modification can be done. How do you cope with that?
So that is a good question. So we have as we've gone through, right, it started out with like 1 or 2 of us, one, I think, Wes to begin with at MSD. It grew to him and myself. Now it's grown to an even bigger group, right? So as part of what we've done as we've gone through with the Flex 2 is develop our own principles and strategies so that we will always go back and look at them whenever we have to make those kind of decisions, right? And then we've also built a mapping document that'll probably be very beneficial for some things that Wolfgang's going to show you. But originally we did it just for ourselves so that if we ever had those questions, we could go back and go, oh, that's what we did for Empower. That's what we did for Flex 2. That's what we did for CDEX, right? So we'll want to make sure we're doing something similar when we go to like Softmax Pro. Does that answer your question? But I mean, it's not easy. But it does require governance, right? So that's one of the biggest things that we're finding is that the business division within MSD that is funding a lot of this effort, they've now really started to realize that developing governance to be able to maintain this long term is going to be vital.
Think about it also, maybe connect. Your converters really are your ultimate mapping document, right? And so that what certainly we'll talk about, I think, during the course of the day is you need to obviously maintain version of your converters. And that's another way you can think about it. If you have a database of your converters, you're living mapping documents.
I love the presentation. There was so much that resonates, right? It's interesting, you're a different company, but it's like the thing. Can you elaborate on the challenges on the other one, right? You put everything in the data lake. Do you see any challenges to get the data out if you do all that process, or you're fully covered, or do you see that there's still some kind of challenges on still in going from the micro to the moon?
Yes, no, that's a very good question. So I'll say that, right, we're working on that now, right? So as we're finalizing and speeding up the converter development and having new ASMs being generated, now we got to really focus on that data lake side, right? How do we combine the data across those different data domains and and I think there's some talks later on UX, and even I think later we have some slides on user experience, right? So we really want to try to, but we do see that all of the work that we're doing with the ASMs are going to benefit us a lot when you start talking LLMs and being able to connect them up to AI chatbots, right? Wouldn't it be great for, you know, when you have a root cause investigation in the plant, you just can type in or simply say, right, Siri or whatever, right? And say, can you show me what the data looked like for this, for MK1234 over the last 6 months? Right? Show me all the data. Don't just show me what my data product was for the quality control lab, because maybe there's more important information that's out there.
Maybe not Siri, but
Well,
yeah. So there's did I answer your question? Yeah, and there is more coming in the presentation. So there's a question online. We'll go to Janet's question. Custom fields. To what extent are these a byproduct of largely non-standardized human-centric processes? In the AI-driven era, with more use of standards and their adoption and AI agents and workflows, shouldn't this reduce dramatically?
another great question. So yes, but we're not there yet, right? So there is an awful lot of past history. And anyone that's ever done cultural change or any kind of change control in a company, especially a large company, knows that is often that shift, right? It's a huge barge. We're out in the middle of the ocean. We can't just turn on a dime, right? So yes, now we have to deal with MSD-derived calculations for a method that was used in our chromatography software, right? But we're hoping that once we enable that, maybe some point down the road, maybe when we come back into a version 2.0 with that, for that ASM, for that software, we might be able to remove some of those custom calculations that users are doing in the chromatography software, because there really wasn't a better place to do it at that time, right? So we're hoping that right now we have to enable it for our end use cases, but we're hoping that we can actually drive a better solution in the longer term. Oh boy.
Oh, I tried to yell. I'm gonna go there because they both were like, man.
I was like, woo.
So
Hopefully-
actually, Mark beat you by a half a second. And we're just,
Excellent. Yeah, I had a question. It was not specifically about what you said, but what you said before. So a lot of the things that you've been talking about are all conversion driven, right? We take one data source, we create an ASM of it. There's lots of challenges in that. But now we have all the ASMs. As you said, for Antonucci, you already have done that. What are some of the outcomes that you have been able to drive with those ASMs?
Great question. So a lot of our first use cases have been to try to automate manual transfer of, say, important key results, as well as then linking up where my results came from back to Empower, right? And putting that back into the notebook or into a LIMS system, instead of having somebody type it or copy and paste, right? Anytime you do a manual transcription, you're fraught with error. So for data quality, data integrity, we've been trying to focus on automating a lot of those manual kind of transfers, because that's low-hanging fruit when you start talking about return on investments, right? And you can actually impact things there. On the other side, we've also been driving a lot of visualizations. Now, I know, for example, when Waters has their suite of things to be able to do system suitability and instrument maintenance, or how your instrument's operating, right? Well, that's great for all of your instruments that you connect to Empower. But who here doesn't just have instruments connected to Empower, right? All of us, right? We have plate readers, we have cell counters, we have qPCRs, we have a ton of other instrumentation that doesn't connect to Empower. So we find driving an instrument system suitability, or being able to understand what instruments are up and able to be used and are actively being utilized outside of a vendor solution themselves, is very important. And we're actually using it now to drive a lot of our fleet decisions. So we have fleet managers looking out over the assets for each instrument base at MSD. And they're using these to have discussions and say, do you really need 5 instruments? Because the 4 you already have are only being utilized 50% of the time, right? So it's very valuable. Does that answer your question?
Another use case also that I'd say is top of mind current, in addition to what Chris said, is also with some of the recent regulatory guidance on assay performance monitoring, is using it for really the obvious use case of assay performance monitoring across an assay that has different instrument and vendors and, a general sort of dashboard. So that's sort of, we started with chromatography and we hope to expand to a bunch of different types of assay types in the next year. Those are some of the top of mind use cases.
Before I came to MSD, I worked for a petrochemical company, and I helped them design and install in their QC labs a monitor. The lab manager could go into the lab, or when they walked in the morning, right, they could look at a board and go, all right, all these instruments are green. I don't have to worry about them. Here's my instruments that are yellow. I probably should investigate those, right? And here's the ones that are red. They need my attention today, right? That kind of thing. So it's important. And wouldn't we love to get into a lab state of the future that we could do that?
John?
Yeah, so let's suppose that this is highly successful. You have your 10 million ASMs that you've created, and the ASM standard improves. So some of your custom fields now become mainstream fields for slight modification. What are you going to do with the data that you've already converted? Are you going to just leave it as in situ? Are you going to rev it up so that to a new version? What are your thoughts about how you might do that in the future?
That's another great question. So we have had to deal with that because we have had to deal with changes that are happening with Allotrope as well, right? So the first thing I would say is you look at a revision that Allotrope does, just like you do a software revision. Does what's in there actually fix a pain point for me? And if it does, then we probably should actually work on using that, right? Converting back data, well, hopefully maybe with AI, even though it's still in there as a custom field in the information, hopefully we can build some additional layers, right? This is where you start talking about different layers inside of your data lake to be able to manage the data, right? So you could start to build some sort of way to map the old field, right, with the new field in once it became, like, for example, like you were saying, a core allotrope term, right? So there are some things that you still have to take care of and consider it, right? So
there's an ISO standard from the early beginnings of the century called Open Archive Information Systems. And that standard makes a distinction between archiving and preservation. But archiving is basically a long-term backup of file. Preservation means an active process. It's a business process with governance that needs to manage like format evolution and then up converting to the most recent.
Yeah, and that's, to my mind, that would be a core part of your business process. You know that things are going to change over time. So therefore, you need to have a mechanism in place for how you're going to handle that in terms of, and I think I get your distinction between preservation and active management. They're different things. Maybe we just have different problems. But,
So Wes, you get the last word, and then
I just wanted to make a comment on Janet's question. And I think we have to be a little bit careful about standardization, not stifling innovation. And if a scientist has a great idea for tracking something new, that's the power of the graph, is it's extensible, and we shouldn't, our goal should not be to completely close down custom information. We should stop things like, I don't like the units, so I'm going to do a different calculation. That we want to get around. But we have to recognize that we're always going to be dealing with information that's not part of our model.
I've recently decomposed custom information for the different qualities. So you actually have vendor-defined fields that Allotrope isn't standardized yet. but they are vendor-defined fields. They are not operator or user-defined. That vendor-defined fields can then have vendor-managed input or can be retext input with line words. And then you have the generic, like custom user field 1 to 10, you can get into whatever you like. And so this is three different qualities. And the vendor fields are certainly candidates for optimization if they are a little pattern across vendors, but also across vendors across pharmaceutical or chemical companies, right? Also from that perspective, even if it's a one vendor only field, makes sense to agree on two. But all custom information I see as a backdrop cross analyzation as a mechanism to feed. Good, so where do we take it from here? As Chris has presented, and we saw that also in the agent presentation, building these converters is a painful exercise. It takes a lot of time, so you do a few a year. So we want to see how can we make that scalable. So currently we see weeks to months or sometimes years on very, very complex data structures, or when the standard is not quite there yet. To build that, there's limited reuse, so often we start all over again, because there's no one standardized like methodology, how to create a library, reuse of the knowledge, right? And the validation is largely manual currently. So what we have been building at ZONTAL over the last few months, it's an AI application that actually standardizes and industrializes the process. And currently, we can build two different types of products. One is converter. So converter is basically a Lego block for a piece of ETL. So you read the format, you transform it to the Allotrope model, and you divide it into the Allotrope standard. And the second one is an adapter factory. So we discussed multiple times already today the OPC UA specification. Right, so ASM is for the data flow, UPC is for the control flow. So if we have both pieces together, then we can start to think about orchestration. So the goal here is to change the economics. Right? So Chris said if you have 50 types, it takes a long time. Some companies have hundreds of types, so probably a goal that you will never finish. And if you're close to the finish line, you start all over anyway, because they do instruments and new requirements or whatever, revisions, whatever happens, all the maintenance, right, will probably also consume a lot of your time. So we want to be able to reduce that to days instead of weeks or months, be able to run things in parallel. If you use AI, right, a human can kick off, in principle, an unlimited number of parallel processes for the AI to process. We can build in the validation. So validation is mainly the review and documentation exercise. AI is very good in creating documentation. So when the AI runs a factory, it can also create the documentation to provide the evidence of what just happened. Right, and we can build reusable assets, templates, knowledge bases. And so when we build the next converter, we can tap into existing mappings and take it from there. Don't need to go through every single detail here, but roughly this outlines how a typical software development lifecycle looks like. So very involved, many manual steps, and driven by humans from start to finish. You can use systems like Jira sort of to organize your work, but in the end, it's all manual. Right, so we want to change that into a very different metaphor. So not just makes the same process faster, but fundamentally change how we work here. And the idea is we have a new process where we put the human in the loop when needed. So AI is driving the process and is coming back to a human, with a human task to like control the process, but not execute it. So the first thing is obviously we need to connect the data source instrument to a network, to a file share, to some API, so that we can ingest the data in its raw form, like we have seen in the Agent presentation, like we bring the data from the CDS and the ECM system, for example. So we need to bring the
data to where the AI can process it. Once we have a test data set compiled, the AI can start doing the work. Right? So the human does other things like doing science, and the AI can build the converter and calls the human back when the ASM is ready for review. Right? We can, so instead of doing like a waterfallish upfront BA specification system design, the AI builds the design for us. So we come back when the design and the code and the ASM is available. We can review, and certainly there may be things that we don't like. So we send another prompt and say, okay, I want to modify, use Mike instead of new, whatever. Right? So this and all would be, if we don't know it already up front, to put it in the first prompt, then we can iterate over it. But iteration just means sending another prompt and coming back later. Then after final review, we still need to approve, and at the GXP, run the validation. The AI will generate us the evidence accurate to templates that we can execute. So that's basically the approach that we have taken. We have a video that shows the system in action. So one thing that we only briefly touch in the video is what is if the Allotrope standard is not quite ready yet, if it's not complete. So for example, when we convert unicorn, right? Obviously we use the Allotrope ASM for HPLC, but unicorn has a lot of additional monitoring information, right? Tons of sensors that run while the system is doing the chromatography experiment. Those are not standardized yet. So what we need is an ability to extend the Allotrope schema with additional data cubes, for example, to capture that information, calibration information, analysis information, which is not standardized yet. So Ben is working on standardizing or documenting how this extension should work. We had some discussion over the last month how to do that, so that we don't need to wait until Allotrope has done a new release, but the factory actually can create a new schema or schema extension. It can create new ontology terms, definitions, and then we show that over the fence to an Allotrope working group, and then they can take it from there. But it doesn't block us with executing the converter build and putting things into production. So I got the question earlier, how can we bring in the edge-built ontologies? So I hope that the next release of Allotrope will have an answer to that as well. So technically it's possible, we just need to agree on the approach how to do it. So let's see if that really works. We need to help volume. Playing would help as well.
Wolfgang. Like going through the online people, did you share the audio when you did share?
I didn't share anything. His fault.
This was done before I got there.
Okay.
Share again.
Welcome to this ZONTAL video series, The ICAD Principles in Practice. In this series, we explore how ICAD principles bridge the operational gap between fair data and the realization of its value. In this first video, we will explore the first ICAD principle: integrate. Achieving integration is to connect every scientific data source to a governed pipeline. Such governed pipelines must capture the point of creation and preserve data in its native format with full provenance. In practice, delivery of integrations must be industrialized in order to effectively scale, utilizing a base of reusable assets that compound to reduce cost and delivery time for future integrations. Integrations must also be delivered quickly. The scale of full integration demands that instruments are onboarded in hours or days, not weeks or months.
It was a short video. What does the internet say?
By ZONTAL, showcasing Converter Factory, ZONTAL's AI-accelerated delivery model for integrations and converters. Converter Factory aims to put your organization in control of scaling integration. Implementation of new integrations is now within the reach of stakeholders at any level of an organization, requested through a centrally accessible and intuitive user interface. The Converter Factory approach adheres to ICAD principles at its core, reducing integration time from weeks to hours. In this demonstration, we will showcase the simplicity with which integration of an entirely new device can be requested and deployed. Here we see the Converter Factory UI. In it are previously requested converters, showing their status from submitted to approved and deployed. We will create a new converter, inputting the desired name and providing context to describe which technique, manufacturer, and instrument the converter should be used for. In this example, we will request a converter for the Thermo Fisher NanoDrop 8. We are able to define the target schema for the converter. Having stated the technique, ZONTAL has already automatically identified the most current Allotrope Simple Model industry standard schema. However, alternative or custom schemas may be defined instead, if desired. We are also able to provide additional requirements for the converter. In this example, we specify custom preferences for the input and output formats through the requirements field. Finally, we provide some representative example datasets, which will be used to create the converter, and then submit the request to Converter Factory. After a short time, the converter is now completed, and the request is ready for review. We can now explore how the converter processes our data and validate its performance. Here we see the input test data on the left and the converted output on the right. Highlighting data within the input file will show the user where it has been mapped to in the output file. Converter Factory also provides design documents which aid in the validation of the converter. These showcase the scope of the converter, including its accepted input formats and output format schema. A vendor field inventory also showcases the coverage of the converter and its data recovery. A traceability matrix further shows how input data is mapped to the new schema, including details of any transformations that have been applied. Finally, we are able to verify performance by uploading a test dataset and running a verification test. Again, the user can interactively explore the input and output formats and save the results of the verification. If, throughout this review, an issue is observed, the user can request a revision of this converter, returning it with details of any issues and instructions for what to change.
Moving still slow. We have the link, you get the idea. So basically, we move from a project-based approach to the factory-based integration, where we have the code generated. We can have a video process guided in the UI. We can request revisions. The documentation is generated so that we can run the validation. And we have only 3 human touch points in the process, maybe multiple videos, but generally speaking, these 3 different touch points to build. And what we haven't seen now in the video, because I cut it off, was we can also then deploy it and actually have it executed on like the real data that's live coming. Maybe pause here for any questions, discussions, comments.
And if there's questions online, just let me know and we'll pause it. Do that maybe before we say. Questions, comments, folks in the room?
And we render the data. So for example, one of the things that someone would like to see that's got an XY plot is the XY plot. So we can see that it makes sense.
So you're forcing me to continue the video. Let's see how that goes now.
It will then undergo a revision cycle. In this example, the converter displays good performance, and we can accept and approve it, staging it for deployment. Our converter has now been deployed to ZONTAL, where it is automatically capturing data and converting it to the specified standardized format. In today's example, we will be showing manual upload of the data so that you can see how the process works. We are selecting an example dataset and manually submitting it to ZONTAL to undergo the conversion. Here we can see that the original data, as produced by the instrument, is compliantly archived and preserved in the ZONTAL platform. Metadata extraction has occurred, as we have requested. A short time after, the vendor-neutral data is converted.
It's the best part of it to win.
Pay for some more bandwidth.
But create a sound.
Converted from the record and also uploaded to the platform. It is linked through its lineage to the original data. The vendor-neutral data is also loaded to ZONTAL Data Hub, from which it can be accessed in the next step of the ICAD path to value, analysis. This includes direct database access to analytics tools such as Power BI, Spotfire, and Tableau. ZONTAL viewers also give us the ability to interact with this data in an unlocked fashion. Here we can see the nanodrop spectrophotometry spectra from the original data as extracted by ZONTAL's converter. In mere hours, Converter Factory has developed and productionized an integration to an entirely new device. This
Other questions? I have a very limited number of videos to answer.
Question online from Janet again. Will the converter factory operate in an open ecosystem model, interoperable with agentic workflows, not in the ZONTAL platform?
So the converter factory itself just builds converters. So we are working on a SaaS offering where this works as a marketplace. So you can choose converters that others have built, or you can build your own converters and share them. Currently, then we can deploy that into the ZONTAL platform. But we're also thinking about building web service on top of it that you can integrate with any systems.
Maybe I'll seed you with one question. Can you say a little more about the ability to predict schemas? I mean, you touched on it briefly, but I think certainly in the experiments that we've been doing with the ZONTAL integration factors, it's certainly one you track. Say more about that.
Yes, so the factory is aware of the Allotrope design principle, so it's all pattern-based. So very systematic framework how to build ASM files. So which is one of the core distinctions between many other standards, so that it was always built as a puzzle-like concept. So we've seen in one of the earlier slides. So based on these patterns, we can easily expand, right? So we know when we have an area of data, how data cube needs to look like. We can switch the measurement values and the units, but basically the structure is defined. So based on these building blocks, then we can easily assemble the new specifications. The AI understands a lot of the scientific part, so it knows how to standardize labels, even from proprietary vendor labeling to a more allotrope conformant way to label things, so that can all be automated and the ontology terms can be invented.
So one last question, maybe then I guess people are seeing my plan of promising you longer lunch, but I really just got more time interpretation, I guess. But that's good. No, conversation is good. From Ricardo online, any plan to convert encoded data vendor files?
Absolutely, yes. It's not a plan, it's already happening.
Last questions? Okay, let's go to the last little block here.
Yeah, so that's one of the changes that we are currently running with MSD here. We need to cut out this whole converter development phase of the project and collapse that into the factory execution process, so which will save us roughly 50% of the time, cutting out all the professional services, and ultimately this will be a self-service capability so that customers or partners of them can just go online and get that for themselves. We want to take it from here?
Sure. So, and as you can see on that last slide, maybe I'll go back real quick, right? So you'll see where I was talking about. Now we our largest chunk, right? You always try to get that lowest hanging fruit to try to squeeze that down as much as possible, right? So now you can see the next biggest chunk, right? So if we can automate this, right, and this should be somewhat easy, especially for that validation and testing wise, right? We'll really kind of scrunch it down to the bare minimum of what we need, and we should be able to produce a new ASM within weeks, right? And a new converter. And so like I kind of talked about, or what we've kind of talked about before, right? So as we've been using this factory and we've been kind of providing feedback and having iterative changes with it, right? That first thing that I showed, right, that was really something that it found, right? So that micro versus the mu, it found that as a difference, right? So that's even something that is not actually an allotrope problem. This goes back to the ontologies. So whenever someone created an ontology for like physical characteristics, for physical measurements, so think micrometer, right? It actually used the micro symbol. But when people used for volumetric, right, so microliter, they actually on the ontology side chose to use the mu symbol, which if you really, I'm not going to go into it, but it actually was a cool kind of rabbit hole to go down into, oh my God, what's happening here, right? So talk to me during a break. But mu is actually probably the right term because it's what everyone has moved towards as we've grown throughout the system. So and we've also found, right? So it's been really helpful for us to find when there's schema changes. So I'll just hammer that home again, right? So one of the things we're working on right now is solo PE, which is multi-path length electronic spectroscopy, which is something that Allotrope has not done, right? They haven't enabled it. So we're hoping to be able to use that to help speed up a schema extension or being able to apply it to other things, right? So, this is also probably on here, right? But there's a bunch of other things that we've caught out here, right? We've also found that One of the things that we did wrong in our mapping document, that I talked about, our principles and guidance, right? We actually found that one of the things we used was actually a detecting terminology instead of a detector. And there is actually, again, not getting pedantic, but it really does matter semantically, right? The difference between detecting versus a detector. So, we even found things out that we were doing wrong, right? So it's kind of, it's really, we've found that it seems to be a great improvement over a lot of our manual way of thinking, right? And so getting back to it, I kind of hit on it earlier. So where we really want to get to for our target state, for like an instruments utilization kind of dashboard, you probably create a persistent data product and data model for it, right? Because it's something that anyone's going to want to use time over time, and you never know when somebody's going to want to use it. So you don't want to constantly use compute time in the cloud to generate that on a regular basis, right? But for doing a lot of chatbotting, to understand, right? So say, for example, you want to build that dashboard to begin with, and you want to start looking at things, right? And doing data exploration. That's where we really see the next shift has to go to, right? We really need to get to a point where we're not creating persistent data models everywhere and data products everywhere for every little new thing. Sometimes you don't know what you're looking for, right? So you might want to ask your first question, and then based off of that information, ask a second, ask a third, ask a fourth. So I think, is this you?
Thank you.
Oh, okay. And so these are some other, this is another big use case that we're seeing right now, right? Lineage. So lineage and genealogy. When we start looking at this, again, this really, really is going to need those ontologies and the semantics, right? So understanding, and when you want to explore, say for example, I just developed MK1234, right? It's the next greatest drug product, right? And when I wanted to go and try to improve it and expand upon it, I might have done a number of children, and then I did children of children, right? And I get out to nephews. Now I found MK235. It behaves vastly different than 1, 2, 3, 4, right? I want to know what those differences are, right? So I have to understand how the lineage goes, right? And maybe I find out that that actually now connects into, I didn't realize it before, but maybe now when I do my data exploration, I find it's actually evolved into slightly a different product, right? And so this really, really is going to become powerful, and we really need this, right? And we can use the semantics on top of the data is what's really going to help us drive for this, and is almost necessary. So this is one of those use cases that now we're finding, we found all that low-hanging fruit, the easy to do stuff, but this is now that next level that takes us one step further, but is very powerful and very much needed to do the full cycle, like what you were talking about this morning, right? To go back and have AI-assisted experimentation, right? To help us design experiments. I think this is definitely you, but
yeah, go ahead. Let me help here. We'll do a little tag team this. So as an example, one of the experiments that we did, we have to use the ZONTAL platform for it, was an example of creating lineage. And this is lineage, think of it as materials. So, anyone who's been in a laboratory, the backbone of what we do in laboratories, we do a lot of virtual things now, but still make things. So this is an example. You can see the key here in the corner, just a quick mock-up we did of various materials. So it's that lineage or that provenance of not only a sample begets a sample in terms of physically distributing, but also linked back to the project, the process, the batch run, and so on and so forth. So it's creating that lineage or that provenance of your entities, and underpinning this was moving towards create as Chris alluded to, taking the various data sources whether it was about materials domain, whether it was about process, whether it was about the results, starting to move towards putting all of those pieces of information into ASMs so that we could not only create the lineage, and you've seen many tools that create this sort of lineage map, but the idea was that any of those nodes that you would go to, which I think for various reasons had to, for this, wipe them and call all label, very interesting. But you would click on any one of those nodes and you would get an information package in ASM format with all the merges of an ASM. So this gives you an idea of how, starting to move towards that vision, you could explore your data in ASM format, connected by design, and traverse it either graphically or in some other format. Which, and maybe this is a little bit of a teaser since I'm already burning up my lie to you, I guess, in terms of time. Maybe a teaser for some conversations later in the day. So this certainly, in conversation with Wolfgang on this as we've been collaborating, but also just in general, these conversations are happening at MSD all the time. Thinking about the traditional approaches for data products, and we'll read the slide if you take a look at it and you can see these, or maybe some of these resonate with you. But as we think about our efforts to create data products, typical relational approaches, they have a lot of benefits for fixed dashboard type of views, and some of the drawbacks that you see here. And this really is making us pause and think about, well, if I had a cloud of ASM or several clouds of ASM repositories with instrument results data and methods and experimental data, all the other different types of information that we talked about, how would that impact my data product strategy? Do I need to assemble the data in one place and create all these views of data? Or can we really move to, as the previous example showed, a model where you're more directly querying your data by semantic hooks? Do you really need to do what we're doing? Yeah. So hopefully that's a topic that we can probe in later in the day if that's really of interest to the group. And this is just, I guess, just continuing to build more and more on that concept of, can we really move to a, certainly that's something I'm passionate about. I wish I knew what the question was to ask, but I just don't. So I need to approach data. I need to be able to query on demand. I need to be able to, as Chris and others have alluded to, I need to be able to explore that data, especially by AI. And I really don't want to have to pause, just really impatient. I don't want to have to pause to create a data product for me to be able to query my questions. I'd like to be able to, on demand, start asking my questions. So again, as a setup, as I promised you, maybe for the next Allotrope Connect meeting in the fall, we can start thinking about some of these consumption patterns. What does this really, if we do this at scale, what does this really look like to us? And then sort of maybe wrapping up, I think this is our last slide, what does future state look like? And certainly this is something in the, I think the ICANN principles, which Wolfgang will take us through after lunch in more detail. It starts to get us to, at least this is our, opinion on putting this together. What does intelligence actually look like? It's the ability to ask novel questions, get instant answers, get extremely impatient. I don't want to wait. I want to get an answer and I want to fire off my next question. I want to have that infinite traceability end to end, not only in my laboratory wet science, but now increasingly in the dry lab science, but also in the AI assertions that we're making in predictions. I need to have traceability. I need to know what those assumptions were and build upon it. So with the hope of faster decisions, fewer manual steps, ideally no manual steps, and that end-to-end traceability for internal and external audits. I think finally, we'll just leave this up here sort of as we open it up for any last thoughts from the group. But I think what we learned together, this is hard, but it's getting easier. And it's definitely getting scalable, more and more scalable. We demonstrated with the partnership with ZONTAL that there are tools out there that do actually, we do believe are game changers. And with the expansion in Allotrope, moving into different data models, opening up more collaborations with projects that start to create the connectivity between data by design, establish lineage between our information. You can actually, in the laboratory, create that spine of materials that essentially say, think of it as the backbone of your data, and then decorate that with all the information that's associated with it. And it, you know, where we really, I certainly would like to help with Allotrope over the next year. Couldn't agree with Wolfgang more on this. It's really all about intelligence. This has all been about a journey to get us to a point of a scalable solution, but now it's about what we do at this point. So it's really about building intelligence into our data. So with that, I believe that was the last slide. Just leave it for any last thoughts or questions from the group before we move on to our next talk. I will check online if there are any questions, comments, thoughts. Hello.
This is fantastic. I was really captivated by your comment. Do we still need to build data products? Okay.
You've never heard me say that. So.
No, I want to unpack this a little bit more in the remit of root cause investigation and in terms of designing a system that help asking intelligent questions. Right? Root cause investigation is never a single root cause. It's sometimes a combination of causes. So I wonder whether we should develop some thought leadership on how we can monitor the established conditions based on the prior science and maybe based on a classical data product that support the classical process monitoring system. When you have your machine learning that has, I don't know, 1 billion parameters. When you have a deviation, how can you leverage what you're already using to monitor the established condition to narrow down the possibility to transverse all your data, all your knowledge graph, and pinpointing multiple apparently disconnected causes that conjure to that deviation. You see what I mean? Mm-hmm. So it would be nice to try and connect these two ways of thinking.
Yeah, and generally by that, you know, that idea that I put out there, I don't believe that we don't need data products, but I do believe we can design data products in a more reusable fashion.
Yeah.
What you described to me, you know, is just a less, maybe a less business biased
yes.
product, a more reusable data product. But notice I keep saying data product as opposed to data products. So where, you know, where you just keep creating a bunch of snapshots for every individual problem that you had to pre-plan beforehand.
Yeah.
So I think to me the goal is creating a reusable small set of data products that allow you to answer the questions that come up upon, you know, when they come up, as opposed to, you know, as we've talked about many times internally.
Yes.
I've heard, you know, somebody asking a question and my response is, great point. See you in 3 months, and I'll give you a data product, and you can answer that question. In 3 months, I'll forget what you asked yourself.
Okay. Yep.
Any other questions or thoughts? You've heard, oh, sorry, one more.
How far do you think we are on the futurism? I have these, you know, you mentioned, right, these technical dashboards. I discussed that many times, right? How far are we from this?
I will give an answer, and then I really didn't manage to go up to 10 minutes of bedtime. But I don't think, and Wolfgang is comfortable, Chris as well, but I don't think we talked about anything on any of these slides that's not doable. It's just
So the chat bots. But
right. The underlying data, a chatbot to peer that data is spun up pretty quick. So we are not doing all of these things yet, but I don't I think a few years ago, we couldn't do them, we can do them. So it's part of the fact to go through the cycle.
We have a number of visualizations that we are actively using at MC. And we're building more and more as we enable more ASMs, right? Because some of those dashboards need to combine information across different instrument types. So